So you can see the magnitude of how common this happens. I mean, you get an electric shock, okay, a lot of people survive them. I mean, majority probably survive them, but it's only because of the magnitude of it or how it entered the next of you. Goes across there, it's a lot worse than it going down there, isn't it? As we well know.
Welcome to today's episode of the Electrical Safety Podcast. Today we have a special guest, Graham Hogg, an experienced EC&I engineer, electrical engineer, and project manager. With over 20 years of experience in the industry, Graham has been leading the design, construction, and commissioning of high-valued electrical, control, instrumentation projects for top-tier operators and EPCI contractors around the world. Graham is also a technical electrical safety consultant with Scanware, where he partners with the industry-leading manufacturer of arc and flame protection clothing and PPE. Join us today as we discuss with Graham his insights on electrical safety and the importance of protective clothing in the industry. Hello, Graham.
Hello, John.
Good to see you. So, to get started, just for everyone, could you tell us your story about, just in general, how you ended up working in the electrical trade?
Strange one, really. I actually started off in the mechanical trade. I started off as a toolmaker a long time ago, and sort of all the work we were doing was a lot of rework, and it wasn't that interesting. And just one day, chance meeting with a guy, and he offered me another apprenticeship within sort of control system integration. So we did a lot in the food industry and sort of power tool industries, a lot of machine builds, automation systems, conveyor systems, and a lot of integration with electrical systems and switchgear and so on and so forth. And as the company, it was only a small company, and as we grew quite rapidly, went into a lot more of the electrical systems as well. So we were doing a lot more of the electrical installation and design, so on and so forth. And I was there 8 years, all around Europe. Really interesting and gave me a really good grounding across sort of electrical control, instrumentation. There was nothing we didn't really get involved with or sort of learn a lot of communication protocols as well, which was good. And that was 2008, and we saw a recession in the UK, and things changed. So I left there, went into plant maintenance for a year, which is not me. Can't stay in one place for time. But I was doing a sort of a new factory build as well as plant maintenance, so it kept it interesting for a little while. Then I left. I got another chance phone call. Would I go to Egypt? So yes, went off to Egypt under a gas compression station, which wasn't in the best of dates construction-wise. A lot of contractors hadn't done what they said they were going to do, so I kind of got stuck in and finished the job off, really. Did a lot with the gas turbine vendors and a lot with the switchgear vendors to bring them online, and then taking out the temporary gen sets and bringing on the permanent feeds. So that was good. I was there for almost 12 months on and off, in and out of the El Alamein, the western desert of Egypt. Then left there, went back into maintenance, but as a maintenance manager in Saudi Arabia. And the reason he wanted me to go as a British electrically trained person was the camps were built back in the late 70s, early 80s, and they were built to British standards. So they wanted somebody who knew the British standards and different way of wire things and stuff like that. So it was a lot of upgrades, a lot of small sort of package substations and distribution systems, 17 in total, and some water treatment plants. It was really, really good. I had 114 guys working for me, and we got the job done, and then I started getting bored. After 2 years, left that, came back to the UK onto another gas site as an electrical superintendent, and was there for a couple of years, bringing on the DCS, all the switchgear, a couple of gas compressors, so on and so forth. Then left there, went back to Saudi Arabia for 26 months onto the world's largest single-phase chemical plant, a $26 billion plant. I was on there, the chlorine and the brine assets, which was huge. And that was really, really good for me because that was more into the sort of NEC code, because it was a joint venture between Dow Chemicals and Saudi Aramco. So that to get me more into the sort of North American way of wiring things, and also that was sort of when I came across the sort of NFPA 70E methods, which is not always, a lot more understood today, but not back then, and we're talking a lot of years ago now, which really intrigued me, how the difference between the UK and the US, and how we non-prescriptive and they have a set of rules, and it was really, really good. So out of the book and read it back to front. That's the nerd I am. So yeah, I was on there, finished that job up. I came back to the UK in the pharmaceutical as the commissioning manager. It was only a small job, a little £5 million upgrade. 8 months, and then I got another phone call back from the gas site in the UK. They were doing a phase 2 upgrade, putting 2 more dehydration trains in, 2 more gas compression units, switchgear upgrades, 33 kV down 4 through 415, and 10 new gas storage wellheads. But this time they asked me to design it. So I did. Designed it, oversaw the installation, and commissioned it. And towards the end, that's when COVID hit, slowed us right down. We were literally finishing off the back end because it was quite a long job. We're seeing through from concept through to commissioning. I went across several years. Like you say, COVID slowed us down a bit, but left a core crew on site and we got it done. Then they asked me to put a solar array in, 2.2 megawatt. So we designed and installed that as well. Little 11 kV package switch room. Several thousand solar panels. And then finished up doing that one and got a call for a chemical plant, which I'm on now. So, and it's an old asset. Very old. It's an ex-ICI site. Some of the switchgears from the 50s. So you don't even know what's installed. It's one of those. So we just putting it in spaghetti at the moment and taking all the old out and putting all new in. So that's it in a nutshell. It's just been an evolution, and as I say, I credit everything back to my apprenticeship, really. Being so broad that I wasn't shoehorned into one aspect. I wasn't just an electrical fitter. I wasn't just a designer. I wasn't just a commissioning engineer. We saw everything through from cradle to grave. So I can slot into many parts of the electrical industry. It's always something I always say here in the UK is people say, oh, I'm an electrician or electrical engineer. I'll always say, what flavour? Because there's so many specialities within the electrical industry. It's not a one title fits all anymore. It's well, with the one trade that has to keep up with consumer technology as well, which moves way faster than we do. So also I'm lucky enough, I was a year ago invited onto the British Standards Institute, so I also sit on EC 78, a live working group for certain components in the PPE sort of arena. And that's really interesting, how slow it takes to get a standard out there. So being engineers, we pick up these standards, whether it's your CSAs or your BSIs, and you think, oh, somebody wrote that and it got put to publish. It's 5-10 years in the making. From the concept of a new standard to it actually going out into publish, it's phenomenal how many hours of meetings and work go into them. So that was a real good learning curve for me as well. But yeah, in a nutshell, that's where I came from to where I am today.
So, Graham, at which point in your career did you start taking electrical safety seriously? You mentioned you noticed early on that there was quite a difference between British Standard and NFPA. It's
a fantastic question because it's one of the reasons I did start taking it seriously. It was, I would say, around about 2012, about 11 years ago. So about halfway through my career today. I've been in this, approximately 24 years. And when I started learning, and certainly as well, still now, here in the UK, we taught to install or we taught to design. We're not always taught how to do it safely in regards our working methods. And as I said, as I alluded to earlier, our HSE is the goal setting and non-prescriptive. So it doesn't tell us how to do it safely. But certainly around about 2012, when I started to get more into sort of HV as well, a lot more, and oil and gas, because within the smaller heavy industries in the UK, we might have sets of rules and things, but with oil and gas, the sort of safety focus was a lot greater, and I think that comes from them having a lot more money. They can spend it on safety advisors, or they can spend it on additional engineers or additional SAPs, APs, authorising engineers, so on and so forth. So they've got the money for the additional roles. So there's less pressure on, say, an electrical engineer within a company. And also they understand our role of the duty holder a lot better here, in the oil and gas industry and chemicals. So 2012 I started to see a lot more, right, there's a focus on this, and it's a lot more slowed down, risk assessments, task-based risk assessments, so on and so forth. But then, as I said, when I went to Saudi and working under NFPA and the NEC code, which was 214, I sort of seen it in a different light. And then 215 was a massive change for me. January 215, my son was born. And I went, hold up here, it ain't just me anymore. I've read this book, I've got all this information. We need to really change how I think around things here. So that's when I started to sort of write my own sets of rules, because I'm a limited company, I'm a company in my own right, and I have guys working with me now, which is growth as well. But I started to write sets of rules, and it was my own work-based risk assessments, and even, like I say, we talk about arc flash and things, the clothing I wear, it would be, well, I'm not going to walk into this switch room without having a base layer on or certain things, and I wrote those in to my company procedures. And I'm also ex-military, by the way. I was military for a short while. So once I write a set of rules, I don't break them. But it was that step change, like I say, when my son was born, and then having this additional information from working with 70, and them having, how do I put it, telling me how to do it, I suppose, for want of a better word. It allowed me to write my own rules, more the British way of working as well. And then I started looking around, and then I've looked at your CSA Z492, which has got some slightly differences in, because it's got its own way away from 70E now as well. So I've taken things in from there, from the German standards, and I'm trying to build up my sort of safe system of work by taking best from around the world. Not the best. Yeah, well, the best good practices from around the world, and build up my own rules. And I do write safety rules, electrical safety rules for companies now as well. And having that understanding of the around the world ways, it allows me to take an old set of rules from the UK, which again was goal setting non-prescriptive, and put in these extra layers of safety from, like say, from CSA Z462 and 70E, which are two fantastic documents. We don't have anything like that here in the UK.
So NFPA gave you the baseline back in 2012? That's where it started?
That's where it started. It was just so informative to be able to pick up this, one of the better words, manual. And not everything in it could be used for the UK, by no means, but it was just this huge manual to go through and understand. And also there's a little go-to book, Uglies. Have you heard of it?
No.
Uglies. They do a few different ones.
Uglies,
Yeah.
the safety rules.
Yeah. So I bought those little books as well and started reading those, and it was really, really interesting to see that this information is pocket-sized and available on the market. But here in the UK, there's nothing published like that. There might be ones about electrical safety and the law, what the law says. We've certainly got fantastic standards. The British standards are amazing, but to get everything that has a component of electrical safety within it, well, we're talking several thousands of pounds, and we wouldn't get any work done because I'd be in a study for the next 10 years to read through them all. And like I said earlier, the standards change constantly. And it takes a long time to get a standard out. It's every 5 years. Whereas, so yeah, as like say, I pick these manuals, and I have a thirst for knowledge, and it allowed me to actually see how easy it was to do things so much safer, and actually it became quicker to do it that way. Once you sat down, took all the information from these manuals, and wrote down your own company rules and how to deploy those safe systems work, it just becomes second nature.
Mm-hmm.
It's so easy. So yeah, it was 78 that gave me the baseline document, yes.
Yeah, so it sounds like you have like a real, almost like a practical way of getting started in electrical safety. You know, your son's born, and you look around and you think like, geez, I really got to focus here. A lot of people, though, that get into safety and electrical safety, they've gone through some traumatic experience or some incident. You know, can you tell us about a time that you were involved, you know, whether it happened to you or maybe it was just the place you were working? Is there something you can remember? I mean, you've been all over the world. You must have seen something. Is there an incident that comes to mind?
Electrical safety one, yes, there's one. I'll come on that in a second. However, in my apprenticeship, we used to do a lot of machine safety, and a lot of our calls were after an incident. So when you say machine safety, guard switches, safety interlocks, things like that, we used to do a lot of that sort of work. And I've been called to a few sort of glass moving lines where somebody's got an arm gone missing, or got called to another one which was a bread oven, big ceramic induction oven, and two guys had gone to do some maintenance. However, they hadn't let the oven cool down quick enough, and they baked, lost radio contact for 20 minutes. I was down there too a couple of days later, put this oven back together, and they literally drove forklift trucks into the side of it, tried to get these two boys out, which unfortunately didn't go home that day.
Mm-hmm.
Seeing other automatic forklift truck systems where they crush people, or wrapping systems where somebody got caught up in. So I've seen a lot of when it does go wrong in machine safety. Electrical wise, I've never personally had an incident. I've had shocks which I shouldn't have had. I haven't had one since realising all of this. Certainly when was the last one time I had one? Probably around about 2009, 2010. Certainly haven't had one since. And I have seen very small flashovers, putting tails away and putting lids back on, and I had one that blew out a lump of steel on me, probably being a bit of shrapnel. But I was too young and underinformed then to understand that was what we now understand as an arc flash. I just, hit a cord with a bang. Do you know what I mean? I mean, that was way back. I was only
So do you think that, like, going back to your apprenticeship, you know, you're fairly young, probably at that time, and you're now, you know, you're not witnessing these incidents, but sounds like you had a few. You know, how do you think that shaped the way you approach safety?
Well, I've seen a lot of gear flash over. Yeah. So I've been called out with a lot of equipment that's gone wrong.
Mm-hmm.
Had one, quite an interesting one. I got called to do a report on a transformer had blown out. It was an auxiliary transformer for a 132 kV outdoor substation. We couldn't understand why this box had blown out. Anyway, I I sat down with another engineer, power systems engineer, and we went through this. And what had happened was we got a fault on a transformer for a gas compressor. One of the windings had gone down on this transformer, a forced air one. And it basically, when we started doing the study, it sent a transient overvoltage into the system to around about the extent of around about 52 kV. But still, we couldn't understand why this box had blown. It was about 5 miles off site. Anyway, started looking at some photos, and I just happened to mention, I went, and connections should be booted. So I started digging back through the company's history and looking at the FAT documents for this transformer, and found that they took the actual insulating boots off because they were getting a bit of partial discharge on them. Instead of fixing the partial discharge, they removed the boots. Got in touch with the transformer manufacturer, and they confirmed, yes, there should be a shrouded boot. So basically, the termination gap wasn't great enough for 52 kV over, and it completely blew this box apart. I mean, studs were off, M8 sort of studs, 3/8. So that was quite another eye-opener for me, was actually, it doesn't have to be something you're doing on that gear. This can be total external influences. I mean, this was 5 miles away in the system. The fault happened, so you could be doing an inspection. Somewhere else on the system causes a fault, but it finds a weak point on your gear, and you're stood in front of it. So it's always a learning curve. I mean, will any of us ever know anything? No, they won't. However, before 2015, when the little fellow was born, in 2014, when I sort of got into these documents and understanding them more, I was doing some work on a motor management centre out in Saudi, piece of Eaton's gear. And I'm working away, I was looking for some niggles on the control side of the this motor bucket. And behind me walked a gentleman wearing a 40 cal suit. He went. I'm there in a shirt and work trousers.
Mm-hmm.
Nah. Anyway, young suit. So, thought nothing more of it, and I saw them off, and he was with some of the Saudi lads doing some training, some switching on another piece of equipment within the same room. And I pulled him later and I said, "What's with the moon suit?" He says, "Well, we've got to wear it on this gear." I'm like, "Why?" That I'm here with meters, and yes, my equipment's live, but I'm nowhere near the actual motor connections. I'm on the control side of the board. He said, "The rules, these company rules." I said, "Well, why am I doing this?" And he worked for the operation part of the business. I work for the construction part of the business. And I'm thinking, well, why is this so different that we're on the same gear? I'm working to construction rules. He's working operation rules, and he's wearing a 40 cal suit. I've actually got this bucket open, and I've got, it was only a 110 sort of control circuit that I was in, but I was in amongst the gear, and all he's doing is switching gear. But because it hadn't been commissioned, it wasn't in a known state, he had his 40 cal suit on, and I was, well, that's intriguing. So that was another learning curve. So it was, while it wasn't an incident, it was a potential. And I just thought, somebody's done a risk assessment somewhere that's put him in that gear. I wanted to know about this. Why is that risk assessment being done? And why is it not being done for me? Or why haven't I done it? So that really opened things up. And like I say, then 215 came, the little fella came, and I just thought, well, how do I sit burned up and explain to the little fella that his dad's an idiot? I can't. I've got no excuse, because it also, and as the little fella got a bit older, you get those child questions. Why? Well, because I was busy. Why? Well, because I couldn't be bothered to go and get my gear. Why? They don't compute in the child's head. So it helped when I'm developing my safety rules. I kind of put that childhood brain into risk assessments. Why can't it be done? Certainly, I use here in the UK. You don't see them much, but I use the sort of job safety briefings, and I've developed them that are from 78 because they're much better than our sort of task-based risk assessments. A lot of task-based risk assessments in the UK they're too generic. They slips, trips, falls, they bits and pieces. So I've took the JSBs and the job safety analysis sheets and further honed them a UK way, and they're so good in triggering your mind when you're doing a point of work risk assessment of the electrical and the electrical bias. I'm not interested in your generic woolly stuff that's outside of a switch room. These are really focused now, so they're really, really good. So yeah, the childhood brain allowed me to really develop them. Why can't I put my gloves on? Why haven't I got it with me? Why have you done it like this? Because a child doesn't understand excuses. If you don't know what you know what I mean.
Well, they don't add up.
No, they don't. Whereas an adult,
Yeah.
The excuse is, well, I was too busy, I was in a rush. And an adult accepts that. A child doesn't. And so that was a funny way around how my brain triggered into doing things a lot safer. But that's how it happened.
Yes, it sounds that it was quite an evolution and very organic process for you, Graham, to get into over the years, just observing things, collecting knowledge. Was there something? If you could go back to the very beginning of your career, what would you wish you knew?
Everything I know now. Taught me all.
Is there something that stands out? Something that really made a difference?
Yeah. I think it was the 78. I think all countries in the world should have that basic document that teaches all electrical workers how to assess risk and what the actual hazards actually are. Because we don't get taught them, we get bits and pieces. So you might be trained to be a journeyman electrician. We just call it an installation electrician here in the UK. And they'll tell you how to put conduit in, they'll teach you how to pull wires, they'll teach you cable sizes, installation methods. But there's nowhere in the training, certainly here, where it goes into any sort of depth about doing that point of work risk assessment, doing that job safety briefing, understanding what all the possible hazards are. And me and John briefly spoke before we started speaking here about you can walk into a switch room and you're doing one job. Or you can walk into anywhere, any factory and electrical installation, you're doing one job, you're putting a new circuit in somewhere, and you're focused on doing that job. Don't see that there's all these other hazards, and so a standard electrician could be putting a conduit into somewhere, but he hasn't been trained to understand the whole electrical system, what the possible hazards are, what can go wrong by him doing that one little thing. We've all seen where people have drilled into switch gear and it's gone bang. We should be taught what can go wrong as well, and how to look out for that, how to watch out for that. And I think it should be about 6 months of our training. Apprenticeship here is 4 years. I think 6 months of it should be about understanding electrical hazards and being able to assess a risk, or certainly knowing when to go, I don't know, I need to go and get somebody else here.
People could really benefit from having a basic course on asking these simple but very important questions. Why am I doing this job the way I'm doing? What can go wrong? What are the risks? And is there anything in the world that I can do to help with this job go smooth and not blow anything up?
Yeah, it is. Like I just said about where I'm working at the moment. This switchgear that's 50-odd-year-old. I'm not going to operate it. I'm not competent to operate that switchgear. I've never been trained on that class of switchgear. I've been trained on many classes of switchgear, but I'm competent enough to be able to go, no, I don't know how to operate that. Could I be trained to? Yes, I could, quite easily, and it wouldn't be a lot. But, and I'm talking about switchgear, that's high voltage stuff, but even down to some of the old LV stuff, open it up, it's not shrouded the same as new gear. So you get a young electrician now and he's being trained on all this new plastic equipment that's ultra insulated. It's great stuff. And then you send them onto an old Federal electric gear board that's with cables strewn all over it, cracked breakers in it, or an old fuse board that's not in a good state. They don't all, certainly through pressure of getting the job done, or he just understands it. If fuse board, it's distribution board, I'll just get the front off. Pandora's box, isn't it? You don't know what's in there. It should be isolated. It should have, what is the status? Too many people even in the UK now are opening even small distribution boards, and they're opening them in an energised state. Opening Pandora's box. And people say, well, you can't disconnect that. Why? Well, all the computers are on it. Well, do it later on when all the computers aren't being used. Do it tonight. Switch it off, open it up, understand its status, do your job, and put it back together. It's it's about being taught that basic way of being able to assess the risk and what to do to get around some of the easiest mistakes that are made and commonly made, or too commonly made, and also globally, I think we should be recording electrical incidents a lot better and getting those statistics out. Certainly here, you only hear about really bad ones. You're not hearing about low-level shocks or anything like that. And we all know that they happen. We out in industry, we hear about, we've got a shock. I mean, how often is that happening around the globe? And understanding how common it is. Like you say, I mean, yourselves or Canada and America do have much better incident recording than we do here in the UK, and certainly in Europe and then the rest of the world, which we don't hear anything of unless it's on the news because something really went bang. But globally, I think we've got a duty to understand that better and certainly incorporate that into the basic training for electrical workers around the globe, so they can see the magnitude of how common this happens. I mean, you get an electric shock, okay, a lot of people survive them. I mean, majority probably survive them, but that's only because of the magnitude of it or how it entered and exited you. It goes across there, it's a lot worse than it going down there, isn't it? As we well know. Ventricular fibrillation doesn't take a lot to happen. So it's a coin toss whether it really damages you or you walk away unscathed.
Yeah, and I think that's something that I've seen. Yeah.
Sorry, John.
No, I was just saying that, something I've noticed, with the electrical safety groups out there now, they're trying to get a lot more focus on shock hazard because it doesn't seem to get the same attention as arc flash. But
it doesn't, because I think it doesn't have the visual. I honestly believe it doesn't have the visual. It's I've explained to some of the lads I work with and other people, and in the electrical industry, we're working with a force you can't see, you can't smell, you can't hear, unless it's going wrong. When it's in its benign state and doing what we want it to do, it's invisible. Only when it goes wrong can you smell it, hear it, see it, taste the bugger, smell it. You know what I mean? So with an arc flash, we've all seen the videos, the test rigs and everything else. It's a bit glorified, isn't it? It's a bang, it's an explosion, and the little boy in us comes out. Oh, that's fun.
Oh yeah.
Well, yeah, it's fun when it's in the laboratory. It ain't fun when you're trying to contain it. Whereas with a shock, still you don't see it. It would have to be a pretty epic shock to be able to see it. I once remember watching a documentary about a guy, and he was testing some of the equipment they use on the helicopters when they were on the lines. There's some facility in the UK. It's like 400 kV sort of magnitude, and he was up on this rig with, for want of a better word, a chainmail suit type thing. Better than that. And he basically went onto this orb and he arced a 400 kV arc, and he's doing this with it. I'm thinking you've got the power of Thor there, son. A lot more nerves than I have, but only then can you, and you could hear it. It was terrifying. I suppose it was a huge Tesla coil in essence, but like you say, shock. Can't see it. It doesn't. It's not got that Hollywood-esque to it. That's just what I say. So I think that's one of the reasons we don't get the focus, and I know certainly shock hazard doesn't get the focus in the UK now. It's very seldom do we see guys putting on the insulated gloves. I mean, mine are all within my safety rules now. They're all straight in the back of the van. My class zeros, my class 1s, 2s, 3s, 4s. If I'm putting class 4s on, I don't know what I'm doing wrong. Plus the fingers don't move in them. And certainly, now that I'm sort of more in a specifying role and things like that, my switch rooms have all got a lot more rubber matting in. We'll have voltage-rated boots on, or insulating boots. It's again because of some of the oil and gas places I work. We can be wearing boots that are actually conductive when we're out on the gas side, because we don't want the static problem. Moving around flammable atmospheres. So it's about training guys that when you're stepping out of that environment and you're stepping into another environment, you need to change your boots. If you're doing something electrical and you're in a hot work permit, for instance, and you're in a flammable atmosphere, so you've established a safe working condition from a flammable point of view, you've done gas tests, get your rubber matting down. You haven't got the hazard, you've got a hot work permit, you've got atmospheric monitoring. You don't have to wear the same. Put your electrical safety gear on now because you've established a safe working condition from a flammability point of view, but you still got the electrical problem. So it's about having those risk assessments in place and knowing that. As electrical workers, we work in every environment. We work in every industry. Everything uses electric, and every environment in industry is different. So the importance of risk assessment in our industry, I think, is far greater than any other industry.
Graham, when you're talking about ESD type situations with the electrical static discharge, and do you see a conflict there between having to wear ESD rated gear, but then if you're doing electrical work,
absolutely,
the standard is asking for the dielectrically rated boots? What is your experience around those two standards?
Well, dielectrically insulated, we don't really have that in the EU yet. We don't have a standard. I know the ATSMs do and whatnot. I do wear dielectrically insulated boots. I have 5 or 6 different pairs of boots. Like you say, if I'm going out onto a plant and I'm doing something to do with exposure protection, hazardous areas, I'll have my ESD on, or anti-static is the minimum. We have the standard 600079 Part 32-1, which dictates the conductivity required by a boot. There's conflict within that as well, because you can buy an anti-static boot, but it doesn't meet the requirement of the anti-static requirement for hazardous areas. So I always wear ESDs because they do. But like you say, you've got an ESD boot on, it's got a proven conductivity. We're working in the electrical industry.
Does it put you at a more risk? From the electrical shock perspective, do you think it puts you at a more risk for a shock?
I don't want to put it to the test. I ain't rolling that dice. So that's why I say, if we're doing something electrical and we explosive atmospheres, we need to open something, potentially explosive atmospheres, and we need to open a piece of electrical equipment. Well, we do the risk assessment, we do a hot work, we do a gas-free certificate, atmospheric monitoring goes in place. We change our boots. The van's already there. Establish, you've got your hot work permit, your atmospheric monitoring in place. Get the ESDs off. If it's a nice dry day, put your dielectrics on. If it's tipping down, get the wellies out. So everything comes into play. Is it raining? Is it not? Is it so on and so forth? Because we know with dielectrics, their protection is vastly compromised if it's tipping down or you're stood in water or anything like that. Also, what industry are you working in? I mean, a dielectric boot, if its sole takes on conductive materials, it's also, I mean, that's written within the standard, the ATSM standard, that its protection is compromised. So are you working in heavy steel? Are you working in a welding shop where there's swarf everywhere? Well, you've got to take that into account. The amount of what ifs within our trade are phenomenal, and it's about that's why I think it's so important that we start to train our workers on being able to make those assessments and understanding, even just walking through somewhere, being able to take in all that information and where are you working, what are you doing? In order to do our job, we train to do our job, but it's about understanding all those different what ifs.
So on that note, I know you've mentioned 70E, but for someone who's looking to improve their knowledge of electrical safety, what resources would you recommend that they look into? Do you have any that come to mind?
Well, I mean, here in the UK, we have guidance from the HSE. We have like HSD 85, 25, GS 38, many different ones there. We also have BSEN 50110, which is operating electrical installations. And again, these aren't taught to our electrical workers what these documents are. We'll be told about the Electricity Work Act, right? The Electricity Work Regulations and the Health Safety Work Act. We taught about those. We taught there is a one. You're never taken through it about what's the content and everything else. I mean, it's very law written. As I say, you've got your 70E, you've got all your offshots from 70E and your guidance documents from that as well. You've got your CSAZ 462s. Those are really, really a fantastic document. Also, there's a German one, the DVI. Don't ask me to remember that number because I never do remember it. I have to go to my paperwork. Also, go to the conferences, the webinar. I mean, now as well with the webinars, what some companies are doing. The information there is fantastic. And also it gives you a lot of leaders into being able to research other things and find out about what are these other documents and these guidances and everything else. There's I couldn't say there's any one-stop shop that I could say where to go to learn what we need to know as electrical workers. I don't know of it. If you can tell me it, I've got my pen.
So if you were put in charge of an electrical group tomorrow, what would be the first thing that goes through your mind in order to show due diligence as a supervisor?
What do they know? Where am I starting from?
So they're not. You would you would check for their test of knowledge, self-audit type thing.
Yeah, self-audit. I mean, like you say, we've all done exams, and they only tell you so much. You can sometimes learn more from having a cup of tea with people about what they know than somebody being able to go to a multi-choice question and give you a 100% pass mark. So having a walk out with guys onto whatever, so you're a supervisor, I don't know, we're working in grain mills or something, walking around, asking them questions, and being able to just do that self-assessment on what do these guys know. And then sometimes as well, you've got to allow people to work, and you've got to stand back and watch them working, and then build up where you're starting from then as well. And then spot audits, I just don't think there's enough done of it, and the importance of it, of supervisors or managers actually just turning up on a job and understanding that the guys are working safely and working to the procedures that you've given them, using the safety equipment you've given them. something I do like to do, and I'll be honest, don't always have the resource to do it, is to ask the guys, you point work risk assessments, I want every single one of them back. I might not read them all, but sift through them every now and again and just pick certain ones up and go, were they actually filling that out? Were they actually assessing that risk? Or were they ticking boxes here? And you know by how much somebody's written into things and how much time they've taken in them. Getting those back from the field, from all of your workers, into a point. It might be a supervisor, it might be a manager, it might be the company owner. And keeping them on record and picking out good and bad ones and then getting guys in there periodically and going through them. And it's not about picking a certain one or a certain guy who's not doing it right. It's about understanding it and having your whole workforce on board with it, and getting feedback from the field, from the guys as well. I certainly think that sort of builds a culture, and I think that is one of the things. Certainly in the UK, you've got to build that culture of safety, certainly in electrical, because when you're working we do work alone sometimes as electrical workers. We do work as teams. So everybody's got to be on the same page to be able to how do we say it? As I said earlier, I was working on a piece of switchgear and then a guy walked behind me in a 40 cal suit. Well, we should have been on the same page. There should have been that culture within that room. That everybody knows what the safe systems work are, why we do it. By involving them in building up your safe system, involving everybody from the boots on the ground, the coal face, right the way up through to senior management. By building up that, by having everybody involved, you build that culture, and everybody takes the safe systems of work on board. Management understands certain things take a bit more time in the field. The guys understand it's acceptable to take that little bit more time in the field. I just think it's everybody's on the same page.
Mm-hmm. So it sounds that you would start by checking their knowledge base and ability to make critical decisions about risk assessment in the field.
I would be out there doing something with them. I'd be ordering them, monitoring them. I'd say, right,
and you would continue on that track.
Absolutely. Some of them would be hypothetical to start with. I'm not going to do it hot. Well, so to say, I'm going to say, right, so we're doing this today, and we'll go out and we'll stand in front of that piece of equipment in its normal operating condition. So I'll say, right, do me a risk assessment to do this job, this hypothetical job. We're going to do that. I want you to do me that task-based risk assessment now. I might have the company's written risk assessment. Give them that, read that first. I want your task-based risk assessment. Write me one out.
And when it comes to doing the risk assessment, is there an important tool or a piece of equipment that you would say, this directly impacts safety of electrical worker? Is there such a thing?
When doing a risk assessment, no, because I can only go from my experience. Every job's so different. I just can't think it can be generalised. I think the only important tool is this.
It really goes back to the ability to make the right decisions on the spot with the equipment, conditions, tools that they're given in the moment.
Absolutely.
So it always comes back to risk assessment and the ability to make the right decisions.
Yeah, I think it comes back to knowledge, experience, competence, and being able to understand the hazards, to be able to assess the risk. I just don't think there is a single tool other than, as I said, what's in our heads.
No, that's great, and I think that's probably a good place to end off on a good note. And we are coming up on time here, so Graham, I'd like to thank you again for joining us today. And I guess if someone wanted to reach out and ask you a question, is there somewhere that they should look you up? Is it LinkedIn or?
Yeah, look me up on LinkedIn. I'm on there, Graham Hogg. You'll see us. I do respond with when I get a chance and I'm doing risk assessments.
Yeah.
In your spare time.
Yeah, between work and family, it's quite hectic. But no, I do respond to people. As me and John have spoken on LinkedIn there before as well. So, yeah, if anybody wants to ask me a question, I'm there.
Very good. Thank you, Graham.